So this is for part B, 7.11. The challenge is to have these objects be able to reach the target at the same time. In order to do that, we need to look at the size of their mass. And we also need to be able to understand that the greater the mass, the greater the force it's going to need to have to accelerate to the same speed. So we're going to try to get these objects to travel at the same velocity. So object A, we are going to start with object A and having object A getting a force of 10. And if we look here, we can see that object B has 2 times the mass. So it is going to need 2 times the force. So if object A is getting 10, then object B is going to need to get 20. So as we see, they are moving at the same speed, so they're going to reach the target at the same time. And the numbers that we need to be worried about is that object A had 10 newtons of force to the right, and object B had 20 newtons of force to the right. So that was for mission 1. For mission 2, we're going to have them going to the left. So object A has the size of a force of 1, so we're going to have, and object B has 1/4. So if object B, we're going to have a force of 10. A is 4 times the size, so 10 times 4 is 40. And exerting the same force. So even though they had a much different force, they're traveling at the same velocity because they had a different sized mass. So this is for mission 2. A had 40 and B had 10 to the left. In mission number 3, object A is 1/2 and object B is 4. So if we have object A going to the left with 10, object B is going to need to go 8 times that because 4 divided by 1/2 is 8. So now that they have the same velocity, they're going to be able to reach the target at the same time. So it's all about ratios and understanding how the larger mass is going to need a larger force to go the same velocity as a small mass. So A had 10 newtons to the left and B had 80 newtons to the left. So that is it for the purple missions. If you have any questions, remember to email.